Example number 7 now, doing another distance, rate, and time problem. So here we have James and Pat, and they're driving from Atlanta to Jacksonville, which is a distance of 310 miles per hour. I'm sorry, 310 miles total. James, whose average rate is 5 miles per hour faster than Pat's. Now he will drive the first 130 miles of the trip, and then Pat will drive the rest of the way to the destination. And if the total driving time is 5 hours, determine the average rate of each driver. Okay, so just like example number 6, anytime I do a distance, rate, and time problem, I always like having my little chart. It just kind of keeps me organized. So I'll just set that up first. You may want to develop something similar. It just keeps me organized in my thinking. All right, great. And it's always the same on top. Distance equals rate multiplied by time. That's how I know this is my distance, my rate, and my time. And then here we can see that we're talking about, let's see, 2 drivers, right? So we have James and we have Pat. Okay, so we can kind of talk about each one and then kind of fill it in. Okay, so let's talk about distance. Well, we know that the total distance between both of them is 310, and they give us a little clue here that James is going to drive, right? James will drive the first 130 miles. Okay, so 130 plus another, 180 will give us 310. So that's how I know what the distance is, because it told us what James was. So he must have picked up the rest of the tab to equal our total of 310. Okay. So now let's let x, oops. Let's see, let x equal, let's see. I guess it's basically the average of each driver, the average speed, average rate of each driver. Okay, so let's see here. How can we make this work now? All right, so we talk about James is 5 miles per hour faster than Pat. Okay, so really we should say that Pat is just x, and then James is 5 miles an hour faster, x plus 5, right? So x really is the average of maybe Pat right there. Maybe I'm just going to go ahead and just kind of change that. Is the average rate of Pat, right? Because that's actually what x is, and then we'll plug x back in to get the average rate of James. Okay, so it says James, whose average rate is 5 miles per hour faster than Pat. So if Pat is x, and then it must be x plus 5. Okay. Now we know that the total time is 5, but we don't know if this is 2.5 or 3, and then this is what the other is. So what we do is we do the same thing like we did in example number 6, and that is you say distance equals rate multiplied by time, which is the same thing as saying if I divide both sides by the rate, I get time is equal to distance over rate. And that's what I want to use up here. So if I want to get my distance, I do distance over rate. So 130 over x plus 5. And the same thing right here, I do my distance over rate. 180 over x. Okay, so check it out. It told us that the total driving time is 5 miles per hour. So that means if I add James' time and Pat's time, that must equal 5 hours, right? So that's how we can set up an equation. We're going to use what we know about the time here. So we'll take James' time. James is 130 over x plus 5. And now let's take Pat's time, 180 over x. And we know that if you add both of their times up, they must drive a total of 5 miles. 5 hours. Okay? And now we're ready to solve for x. Okay, and that will give us the average rate of Pat, and then we can plug it back in to get James right there. All right, so a lot of practice in this chapter on solving rational equations. So first we need a lowest common denominator, which is basically multiplying these. So it's x times x plus 5. Okay, so if I want this to be that as a denominator, all I have to multiply this by is x, right? So I have to multiply that by x. And then if I want this to have x times x plus 5, I have to multiply this by x plus 5, multiply that by x plus 5. And then this just needs both, right? I have to, if this is 1, then I have to multiply this top and bottom by x times x plus 5. So x times x plus 5. You see? And check it out. Now we have a common denominator everywhere. Everything has x times x plus 5, which means now we can just go ahead and deal with just the numerator. Okay? 130 times x is 130x plus 180 times x, 180 times 5 is 900. For here, let's just do 5x. I'm going to do 5x. I'm going to multiply these guys right here and multiply that by x plus 5, and then we'll do that here on our next line. Cool, so adding these guys together, 310x plus 900 equals, now I'm going to go ahead and distribute. 5x times x is 5x squared, and 5x and 5 is 25x. And so since I have a quadratic at power 2, I want to move everything over to one side so then I could just pretty much factor it and kind of go from there. So I'm going to subtract 310x, and then I'm also going to subtract 900. Okay, so those all cancel. I get 0 equals 5x squared minus 285x minus 900. Okay. They all have a 5 in common, right? So if you want, you could divide everything by 5. So I could divide both sides by 5 just to make it smaller numbers. So I get x squared. What's that? Minus. Let me think here. Is that going to be? Let me do that. And that would be negative 57x minus 180. All right, great. Now, this may take you quite some time to kind of solve this by hand and try to find the factors of 180 and 57. Maybe, maybe not, you know, whatever that's going to give you there. So if you want, you could use Wolfram Alpha. I'm a huge fan of that. And I kind of just did it from the original equation of 5x squared minus 285x minus 900. Okay. If you say solve that, and then it gave us negative 3 and 60. Okay. But we throw out this extraneous root because you can't have a negative rate, right? Even if you travel backwards, you're still traveling at some kind of positive rate. So we're going to throw away x equals negative 3, and then we're going to use x equals 60 here. Okay. So that's what we're going to use right there. So we'll say x equals 60. Now we come all the way back up here. Well, 60 what? Like, what does even x even represent again, right? Sometimes we get lost in the mix of our math. X equals the average rate of Pat. So Pat travels at 60 miles per hour. And then James travels at 65 miles per hour, right? Because it's 60 plus 5. And there it goes. So now we got both of their average rates right here, which it says to find each of their rates.